Hi, my name is Diego Ledesma. I want to show you my data engineering project. This is the Cuversity's 2026 cohort technical project. Cuversity is a data engineering bootcamp created by Cubica, which occurred in multiple cities at the same time, and I had the opportunity to participate in it in Cali. So this project is about creating an ELT data pipeline for a fictional fintech company in Latin America with customers from 7 countries. And it consists of creating a data pipeline which implements a medallion architecture for the data model, and it will end up with analytics ready data in the golden layer of the medallion architecture, which will be consumed by Power BI, used to create some visualizations in a dashboard that will allow to answer a series of business questions. This document here is the specification of the project, and I want to talk first about the architecture of the project. Okay, so this is the target architecture for the project. The tools interacting here are Airflow, which is in charge of orchestrating all the tasks in the pipeline, from the download of the data from the cloud to the creation of the tables in the golden layer of the medallion architecture. PySpark will be used for downloading the data, creating the raw reference, and apply some very basic structural transformations to the data. dbt will apply most of the data transformations. It will clean the data, create the analytics ready data in the golden layer. dbt has some macros that automate some transformations, and dbt is also in charge of testing the quality of the data as well as the proper working of the macros. Finally, Power BI, which is not orchestrated by Airflow, is outside of the pipeline. Power BI will take the tables in the golden layer, which are ready to be visualized, and creates a 4 pages dashboard that allows to visually answer the business questions given in this specification. Okay, let's see the containers. Everything in the pipeline is containerized, and the containers are managed and connected using Docker Compose. The first container is the Postgres container, which is the only container with persistent storage. Here is where the medallion architecture lives in, and it's also where the Airflow metadata is stored. Since Airflow requires the metadata about the DAG, the tasks, and the state of the tasks when they are running. The second container is the Airflow container, which is a custom image that needs to be custom because it requires OpenJDK in order to execute PySpark. And this container also includes dbt. So this container is for Airflow, PySpark, and dbt. The three are executed inside this container. And the last container is the dbt container, but this doesn't make part of the pipeline. It's just a developer convenience, is for manual testing, but it's not orchestrated by Airflow, and it's not part of the data pipeline. Okay, let's see the pipeline in action. Let's see the state of the containers. Everything seems right. I just built up everything some minutes ago. So we can now connect to the Airflow UI, which we connect to using the port 8080, which is the port used by the Airflow container. The DAX name is Cuversity Fintech Pipeline. Let's run it. Okay, it's executing. Let's see the tasks. You can see the tasks here. Create bronze schema, download from S3, load bronze, validate bronze, create silver schema, the flattening of customer accounts, transactions, loans, and validate silver PySpark, which is the last task, done with PySpark. From now on, DBT does everything, and DBT only needs two tasks, which are DBT build silver and DBT build gold, because the DBT models takes care of each step, including testing. The testing of DBT was run using DBT build, meaning that the testing interleaves with the running of the models. So in case a test fails, everything stops right away. And in case there is bad data, that bad data doesn't get propagated to uh, subsequent models. So it's better than do DBT run first and DBT test at the end. Okay, it's about to finish. There are multiple tests. So the DBT tests for uniqueness of the IDs, not nulls, referential integrity, as well as singular tests for specific verifications like that a certain field should have a numeric value in a certain range. And it's done. Everything is okay. So I prepared some commands. Let's enter PSQL, the Postgres container. Okay, let's see first the schemas. We have bronze, gold, silver, and public. Okay. Therefore, metadata is in the public schema. Okay, let's see bronze. We have the raw reference in bronze. And the spec says it's about 5,000 customers. And we have 5,100. Great. Let's see silver. We have the staging tables created by PySpark, and we have the fact and the dimension, the dimensions created by DBT, which are actually the clean data used to create the gold tables. Let's see how many accounts we have. This is about 3 times as many accounts as customer, which is consistent with the spec that says that every customer every customer has between 2 and 5 accounts and between 5 and 30 transactions. Let's see referential integrity. So uh, we're looking for account IDs that appear in the transactions fact tables, but they don't appear in the account dimension. And the returned rows is 0, which means that there is referential integrity. Let's see code now. We have 21 tables. These tables are ready to be visualized in Power BI, and they are directly related to the 24 business questions given by the specification. Let's see an example. And we have gold revenue by segment. So for each customer segment, we have how many customers are on that segment, the average revenue per customer in USD, and the total revenue again in USD. The balances, the amounts were originally in multiple currencies from several countries. So everything was converted to US dollars to be comparable and to be consistent. And let's run some DBT tests. So here are the tests for silver. There are 76 tests for silver, and everything passed. So here are the business questions given by the spec. There were 24 in total. The spec asked to answer at least 21 of them. All 24 questions were answered in this project. They're divided in these categories here. The spec also says how the dashboard must be structured. It should have 4 pages, each of them answering a certain category of questions, which are not exactly the same categories listed here. In the document detailed readme.md in the repo, you can see the details about what models in the golden layer were used to build each of the visuals in the dashboard and their location, and what visuals in the dashboard are required to answer each of these questions here. This is the executive overview, which is the first page of the dashboard. I don't want to stop on each visual because first, for time, second, to have the details in detailed readme.md, and third, because we're working with synthetic data here. So we want to be able to extract very interesting insights from the visuals. Distributions are random and mostly uniform. What I want to show here is that the pipeline works, that the spec requirements were met, and some of the functionalities of the dashboard. So we can select loan types here and see the outstanding balance by loan status over here. We can select a specific city and see how many customers do we have in that city, or a specific country and see how many customers do we have in that country, the total transfer value. We can select a specific currency and see transfers value, transactions value, and transactions count for that currency or group of currencies. And we can select if we want the information to take into account only international transfers or not. Here we have revenue and transactions. We can select, let's say, a specific channel or group of channels and see the average transaction size for them. Here is risk and credit. We can select a country and see the credit score quality distribution there, or group of countries. And finally, we have customer engagement, where we can select a specific customer segment and see how many customers do we have by age group. So here is the model view. Some of the tables need to be connected. There are a couple of intermediate tables as well, but for most of the models from the golden layer, they were pretty much ready to be visualized. So this was my data engineering project. Thank you so much for watching.